All right, let's get right into it. If you're building anything with AI or, prepping for a big technical interview, there is one concept you absolutely positively have to master, and that's chunking. So, let's break down exactly what it is, why it's so incredibly important, and of course, how to get it right.
It's a totally fair question. We have these ridiculously powerful language models, so why can't we just, drop in a 200-page PDF and just ask it a question? Well, the answer really gets to the core of a fundamental limitation in how these models work, and it's the reason chunking isn't just a nice-to-have, it's absolutely essential.
So here's our game plan for this session. We're going to start with the why, the real need for chunks. Then we'll dive into the nitty-gritty of size and overlap. After that, we'll look at the pretty serious risks of getting it wrong. And finally, we'll see how it all comes together in practice, with some actual code.
Okay, first things first. Let's establish why chunking is the absolute non-negotiable first step. I'm serious. This isn't just some optimization you do later. It's the foundation of any high-performing RAG system. Without this, you're pretty much setting your AI up for failure right from the get-go.
Think about it this way. Feeding a giant document to an AI is like asking your friend to find one specific sentence in a 200-page book without an index or chapters. It's going to be slow, super inefficient, and they'll probably get lost in all the noise. But by breaking that book into focused chapters or even paragraphs, our chunks, we make that search incredibly fast and precise. And that, of course, leads to much, much higher quality answers.
Now, the really crucial part here is when we split. It has to happen before we create our embeddings. See, an embedding is basically a number version of meaning, like a set of coordinates that plots a piece of text in a giant map of ideas. It works best when the text is focused. If you try to embed a whole document that talks about refunds and shipping and privacy, the meaning gets all mushed together, it gets averaged out. The embedding sort of represents everything at once, but nothing clearly. So when a user asks about refunds, the match is just weak. By splitting first, each little chunk gets its own sharp, clear set of coordinates, which makes retrieval way more accurate.
Okay, so we're all on board. We know we need to split. But how we split? Well, that's where the real art and science comes in. So let's get into the mechanics of two key things, size and overlap.
First, let's talk about chunk overlap. It's a really simple but incredibly powerful technique. All we're doing is intentionally repeating a little bit of text from the end of one chunk right at the beginning of the next one. You can think of it like a safety net, just to make sure we don't accidentally lose critical information right at the breaks. And this is why that safety net is so important. Just imagine your splitting logic cuts a critical sentence like this right in half. Suddenly, chunk 1 has a condition with no resolution, and chunk 2 has a requirement with no context. On their own, neither chunk makes any sense. The full meaning is just gone. Here's a really great way to picture this. Imagine you're trying to take photos of a super long banner. To make sure you can piece them all together later without any weird gaps, you'd naturally make sure each new picture slightly overlaps with the last one, right? Well, chunk overlap does exactly that, but for your text. It just ensures a seamless, complete understanding of the whole document.
Okay, now for chunk size. And honestly, the pizza slice analogy is just perfect here. A large chunk is like a big slice of a supreme pizza. It's got a little bit of everything, right? Lots of different toppings. This gives you more context. A small chunk, on the other hand, is like a single topping slice. It's very specific, very focused, which is awesome for precision. Which one you want really just depends on what you're trying to do.
And that brings us to the core trade-off you'll always be making. Do you need more context or do you need more precision? Larger chunks give you that zoomed-out, big-picture context, which is great for complex questions, but all that extra info can make retrieval a bit less precise. Smaller chunks are fantastic for pinpoint accuracy, but you risk losing the surrounding information. So there's no single best size. It's all about experimenting to find that sweet spot, that perfect balance for your specific data and your application.
So this brings us to a really critical point. Getting your chunking wrong isn't just inefficient, it can directly lead to one of the biggest, scariest problems in AI today: hallucination. Where the model just starts making things up.
See, poor chunking creates poor context. And that's a recipe for disaster. If a chunk is too big, the LLM just gets swamped with irrelevant noise, and it might just start guessing. If it's too small, it doesn't have the full picture and has to invent the missing pieces. And like we just saw, if you have no overlap, you can literally hand the model a broken sentence, basically forcing it to make up an ending.
I mean, this is a perfect example. If this is the only piece of context the model receives, what is it supposed to do? Returned in its original box, good condition, within 14 days? The model is forced to fill in that blank, and that guess, that's a hallucination.
So let this sink in. The crucial takeaway is this. Good chunking is your first and honestly your best line of defense against hallucinations. By giving the model clear, complete, and relevant context, you dramatically reduce the chances of it going off the rails and generating bad information.
All right, enough theory, right? Let's get practical. Let's look at how we actually do this. For any developer, it really just comes down to using the right tool for the job.
A very popular and super effective tool for this is the recursive character text splitter, which you'll find in libraries like LangChain. What makes it so smart is that it doesn't just blindly chop your text at, say, 500 characters. No, it tries to make cuts at logical places first. It respects the document's natural structure, and that makes it a fantastic default choice for most kinds of text.
And here's how it works under the hood. The splitter has this hierarchy of separators it tries in order. First, it'll try to split your text by paragraphs. If those chunks are still too big, okay, it'll move on to line breaks. Still too big? Then it tries splitting by sentences and so on. It's like cutting a cake. You always try to cut along the existing lines first before you go making new ones. It just makes sense.
Okay, now here's a little pro tip for you. When you're using the splitter, there's a fantastic little parameter you can set called add start index equals true. This just tells it to record where each chunk began in the original document, and this is incredibly useful for traceability. It's like putting a page number on every photocopy. You always know exactly where that snippet of information came from, which is just invaluable for debugging or for linking a user back to the original source.
And this right here, this is the beautiful result. You feed your one single large document into the splitter, and what you get out is a clean, structured list of these smaller document objects. Each one has the text content and all that useful metadata, like the source file and that start index we just talked about. Your text is now perfectly prepped and ready for the next stage in the RAG pipeline, which is embedding.
So we'll end on this thought. Chunking isn't about finding one single perfect number. It's a strategic decision that sits right at the heart of your RAG system's performance. As you start your next project, the key question you'll have to ask yourself is this. How are you going to tune your chunking strategy to strike that perfect balance between giving the model enough context to reason properly and keeping it focused enough for that pinpoint accuracy? The answer to that question is going to define the success of your entire system.